remind me, what do we have at the moment that would suggest a direct relationship or direct variation between two variables? Or how would we know it was direct? Well, can I ask you to be a bit more specific? It passes through. It could be a chicken just wandering around. What points? What data?
The line.
What line?
The equation makes a line that passes through the point.
The equation makes a line?
The equation states a line.
Oh, the equation, like, what's that word? Like, presents a line that goes through.
Should we just go with the fact that when one value is 0, the other one has to be 0? Yeah? Because a line doesn't go through 0. You're making me sound like I've got to physically animate it every time so the line actually goes through 0. We need to get out of that way of thinking, don't we? The line doesn't do anything. There is no snail trail leaving a trail of mucousy slime along your, the line does not go anywhere. The line is what?
Stationary.
There is no line. It is an infinite number of points. It just so happens then that one of those points must be 0, 0. So when one of the variables has the value of 0, the other one has a value of 0. Now you might think I'm being a bit picky saying these things, but I'm telling you that a lot of the misconceptions with things comes from thinking of lines going through places, okay? And not thinking of a line as an infinite number of points that represent whatever we're dealing with, right? So a direct relationship, one of the points will be 0, 0. Okay? What else? Izzy said something. Completely the wrong context, and she probably didn't get it. So there is a constant point. What does that mean?
As the y value increases, the x value increases.
See, didn't we say by the same
Value. Rate. By the same proportion.
Number. Scale.
So the two values, x and y, p and q, whatever you call them, maintain the same proportion, yeah? So if one is 2, and if it's 2 and 4, what do we know about the relationship?
Times 2 or plus 2. Times 2.
No.
It can't
Never
be
gets
plus.
on
It
with
can't
plus.
be plus.
Yeah, good. It's going to be you multiply by 2. You multiply one by 2 to get the other, always. Yeah, so that's where it has a constant proportion. You take 1, you multiply it by 2, you get the other one. All right? K could be any value, right? Can K be negative?
Yeah.
Can K be a fraction?
Yes.
Can K be a negative decimal?
Yes.
Yeah.
Okay. All right. So is direct proportion, as one person, so I won't name you because you're wrong, is it always as one increases, the other one increases? No, because if K is negative, what do you get? As one increases, the other one will.
Then wouldn't that be?
No, that's when it just
What do you know about the two variables, though, if we're going to have a negative value of K, when one is what, the other one must be? Okay, yeah? Whereas if we have a positive value of K, then they are or
That's negative.
both negative. Okay. Now, if we have inverse proportion, what does that look like if you were to plot all the points? That's going to look great on YouTube, by the way. You going like that. It's not a U, is it?
Reciprocal.
So it will look like a reciprocal function, won't it?
Wait, so if it's a straight line, it's never inverse proportion.
Oh.
So no, an inverse proportion, will it ever be straight line? Good question. No.
And if it's a parabola.
See, that's the next thing, isn't it? So we did inverse, things like that. And then at the end of last lesson, we said, actually, there doesn't need to be just a direct or an inverse relationship directly between the two variables. So we looked at this formula, which was the area of a circle right? The area is related to the radius. In what way? Well, we know that the area is related to the square of the radius, not just the radius. So this is what people look for when they try and find equations to work out the areas of circles and blah, 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 the circumference of a circle. So we worked out, well, no, we didn't work anything out. We already know this, that the area is related to r squared. So A, we can say, can't we, that A is directly proportional to what? R squared. Okay? And we showed here that what is K? What's the constant of proportionality? Pi. Okay? So pi is a constant. Right? You didn't recognize it first because it's a different letter, but that's what it is. And we said things can have a relationship in different ways. So we've got two things that share a relationship between r squared. We had things could be related by cubing, one of them. We could have the square root. We can have any mathematical function. Okay, but what must be true for all of them? And
when one is 0, the other is 0.
when one's 0, the other's 0. It must be true, shouldn't it? What's that going to mean? That there's never going to be a what on the end of our function?
Plus b.
Yeah, a plus b. Yeah, plus c, whatever you want to say. Okay, so this is what we're now looking at. So let's, can you open up? We'll go through a few questions now because this might help you sort your homework out. All right. Can we turn to page, let's do example 4 on page 395. Okay.
What's the title?
The title is, as it says, we're looking at different types of variation. We're going to start with the example on page 395. All right, so I'm going to do example 4. And maybe this will help you get to grips with the stuff on biomass. You all got it in front of you? It's been up there for ages, so, you know. I was even nice and I didn't give the other two people their extra homeworks.
Who's that? Oh. Well, because it was a lot. There was like 4 things.
Yeah, there was. But that means they've got to be super good on this one. There's no. Right, shall we have a look then? The light intensity on a movie screen varies inversely with the square of the distance between the screen and the projector. All right, so we've got to take what we can out of that. All right. So, what can we say?
Light intensity.
So light intensity, should we give that an I for intensity?
Fishy.
Varies.
Is that like what that's called? Like, do you just say varies?
Yeah, that's what it means.
Okay. 1 over.
So it says it varies inversely with the square of the distance.
1 over
so
d squared.
1 over d squared. Yes. Okay. Quite often, by the way, people make mistakes because it says the square root and they write square. Right. So do you see how I chose which one was which? Would it matter, by the way, if I did it this way round?
No, but I was doing it wrong.
Would it matter if I did...
Yes.
Yes.
Because that's what I was doing.
This one, I'm not... That doesn't make it right, does it? This one's okay. What would I end up differently, though? What would I end up with a different result for. Because obviously the next stage is to write that therefore I is equal to k over d squared. So in this case, I could write that d squared is equal to k. But what would be different in those two things? Well, you had this in the way you did a question, didn't you? Remember, you came up with a different version of what k was. Because it depends which way round you do things, you're just going to change what k is. Because obviously, if I take one number and I always double it to get the other one, what do you say the opposite way round?
Divide by 2.
Yeah, so it's not doubling it, it's not multiplying by 2. So k would be 2 in one direction, and what the other direction?
1/2.
A half, yeah. Because we always multiply. So that's what we'd be looking. So if I did it this way round or this way round, I am just going to end up with a different value of k, but it will give me the same answers in the long run. So then it says, when the screen is 3 meters from the projector, so that means that when D is 3, it says the light intensity is 24. So I equals 24. What does that information allow me to work out? K. So I can put 24 equals K divided by 3 squared. So then I've got 24 multiplied by 3 squared will be K. Now if I did it this way round, I'd end up with 3 squared is K divided by 24, but I would still end up with 24 multiplied by 3 squared is K. So what is it?
216.
Okay. So I've ended up with okay. Yeah. Right, so then are we all okay at that stage?
Yes, but then
So-
after that,
There's bad after that?
There's nothing else to do.
Well, that's pretty much it. Then it says, describe what happens to the light intensity when the distance between the projector and the screen is halved. So if the distance is halved, the distance becomes 1.5, and we want to work out what I is. Now we know that I is found by doing 216 divided by 1.5 squared. That's the bit people forget. They forget to square it. Right? So what's I in this case? No calculating. No calculating.
because you have one of them, so you double the other one.
It equals syntax error. Oh, I know. No, I know.
Have you done it?
I know, it's like-
96.
Oh.
Why have bullets me?
What did you fall from then? Fall foul of in that point, Neil? Because you said if I double one, the other one will half. But that is what? That's purely...
Assumption.
No,
Direct.
that's inverse when they're both related.
Wait, is that?
But this is the square. Do you remember I said one of the big examples is the speed-force equation, isn't it? Right? So, do you know the equation for force, sorry, that links force and velocity?
Oh, it's like time.
It's
I
force is mv squared.
Not what I said.
All right?
5 years.
This is an example of, right, do you know what v is?
Velocity.
Velocity. So what is m in this case?
Mass.
Mass. And if you're talking about a person on a scooter going on the road, what is the constant? The mass, yeah? Unless you're losing weight quite rapidly while you're, riding along, but it will be a constant. But what will not be a constant will be your velocity, right? So in that case, I've said if I double my velocity, all right, my force that I hit the wall with is actually quadrupled, yeah? So it's the same in this case, although it's inverse. I have halved my distance, but what has actually happened?
You have quartered your quartered your
So it was 3 and
1/8.
24. So D has been divided by 2, and I has gone from 24 to 96, which is multiplied by 4. Okay, so that one was multiplied by 4. All right, so when the relationship is squaring and inverse, all right, if I double one, the other one gets divided by 4. If I multiply by k one side, the other side gets divided by k squared, right? If it's squared, if it's cubed, you know what's going to happen, don't you? If I double one side, the other one is going to be divided by... If it's cubed, the relationship is cubed. If I double one side, the other side is going to be divided by... Don't you know?
Is it on?
It is on, yeah. Let's have a look then. Let's talk about it. So it's not the one that... Ah, there you go.
But why?
Why
You have
is it
80.
Oh, it's cute.
Oh.
I
Yeah,
swear.
exactly. So if I said to you, right, let's say I is equal to k over d cubed in this case. Let's use the same situation, but, right? So this time, when, let's say when d is 3, I is, what should we go for?
17. That's a gross number. 16.
No.
All right, well, let's go with what Neil said, 12. I don't know whether it's going to be nice or not. All right, let's work it out then. So 12 equals k divided by 3 cubed. So that's 12 multiplied by 3 cubed is k. Therefore, 12 multiplied by 27 is?
324.
Okay. So this time I've now got I is equal to 324 divided by d cubed. So if let's double d. So what if d is 6? What's going to be I? So I will be 324 divided by 6 cubed.
Nine. Nope. I checked it wrong.
What's it?
1.5. How did you do it so fast? Oh.
Now, do you notice this one then? It's quite nice because what's actually happened is this. D, okay, was multiplied by 2. And I was divided by 2 cubed. Because what is 12, here look, divided by 2 cubed? 12 divided by 8, which is 1.5. Okay. So, let's maybe we can summarize it a little bit there. Well, the reason is because, do you remember you had a question where it said if you were to increase each by 20%, if you increase one by 20%, what happens to the other one? Yeah?
Well, questions?
I don't know.
Did I do that?
No, it's not on mine.
But what you need to do is realise the process. So what do we have got so far? Right? We've got direct variation, okay, which is just, let's say, A is varies as B, and what do we say? Well, when A is multiplied by K, what happens to B? Multiplied by, sorry, but K, yeah. Okay, they're both multiplied by k, right? If then we have inverse variation, and that is a is proportional to 1 over b. So if a is multiplied by k, b is, so let's say a multiplied by k, I'll do it this way around, a and b. A is multiplied by k, but b will decrease and is divided by k, or multiplied by 1 over k. So that would be b. Okay? So that's your inverse variation. Now, we have the same things, but what if it's different variation? So what if we have still direct variation, but a is related to b squared? Well, if a is multiplied by k, what happens to b? Multiplied by k squared. Okay? Ooh. If you'll get the idea in a minute. If a is relates vary to b to the power of 3, if a is multiplied by k, b is multiplied by k cubed. Yeah. Now with inverse variation, though, if we've got a is proportional to 1 over b squared, if a is multiplied by k, b is divided by k squared. Yeah. If a is inversely proportional to b cubed, if a is multiplied by k, b is divided by k cubed. Okay? All right, so what did we have as k again? Originally? Yeah, okay. So we've got I is equal to k divided by d squared. And it says, part C, the distance between the projector and the screen is increased by 25%. So I've put on here, look, that whatever you do, so we've got inverse, look, and we've got inverse squared. Whatever you multiply by, the other one has to be divided by that squared. Okay? So what we need to do is figure out what mathematical operation do I actually do if I want to increase, d by 25%. No, we can't do it like that. We've moved on from that, surely.
Okay, you multiply by 0.75.
Now we're going to increase by 25%. What is the proper mathematical way that we need for geometric sequences?
Oh, times 1.25.
Good. Multiply by 1.25. Or, but that's finding, right, so you've got to understand the first way when you did percentages, you increased by 25%, you got the number, you divided it by 4, and you added it on, yeah? But that's a two-step process, all right? And that becomes less and less useful as we go on in maths, right? That's why you were introduced to this point of, well, if I increase by 25%, I actually want how much? 125. So we can do that in one step, which is by multiplying by 1.25. So if d is multiplied by 1.25, what will happen to I?
It will be divided by 1.25 squared.
Okay, so let's try. Or is the same as I multiplied by 1.25 squared, 1 over that, yeah?
Yes.
Right. Now, what I'm getting at here, you notice on my screen, I haven't put any numbers in for D and I. Because this is, sometimes it says, the distance between is increased by 25%. You go, from what? Well, it doesn't matter. Yeah, the effect will always be the same. You're being asked, what's the effect? It's like, what is the effect of putting more water in your drink?
It's diluted.
It gets diluted. That's what we're really after, yeah? But how much did you start with? You know, it's still going to be diluted, you know. It's, so what do we get then? What does I end up being multiplied by? If you simplify 1 divided by 1.25 squared. Tappy tappy button thingies, magical calculator thing in front of you, some of you.
I love it.
I wasn't looking at anyone.
You looked right at me. Calculators are really expensive, and I have to buy new ones.
Trade your phone in. Phone him up.
What? Why am I stupid? I'm not finding it. I have a question. I'm confused. Where did the 1.25 come from?
Yeah, because you're
Increase by 25%.
Isn't 25% 0.25?
Yeah, but you're increasing.
Right. If I want to increase by, I need to find 125% of D. How do you find 125% of something? You multiply by 1.25. If I want to decrease by 25%, yeah. That's based back to basics on percent. Okay, well I've just done. What is, instead of dividing by 1.25 squared, because remember, so what I'm saying is, if increasing by 25% is multiplying by 1.25, that means K is 1.25, yeah? Therefore, what effect does that have on the other thing? It needs to be divided by 1.25 squared, or multiplied by 1 over 1.25 squared. So what is it? Do it on your calculator. Show me. I'm trusting what Sam said. I have no idea whether he's right or wrong. Yeah? Right, so then we look at it and go, right, what percentage-wise is the same thing? Well, what do I get if I multiply by 1.64? Okay, well, is it an increase or decrease? It's a decrease, isn't it?
It's 64% because it's not 100. It's not 1.6.
So I'm going to, yeah, no.
It would be
Decrease by
64.
36.
Where's 36 coming from?
Decrease by 36.
Oh, okay, right.
Yeah, so, right.
Right.
And so we're,
The difference
guys,
from the
we
100.
are finding a huge gap at the moment, aren't we? All right? This is a gap that you shouldn't have at this stage, which is because calculating percentages. So if I want to find 10% of something, do you all know how to do it?
Yes.
Right, do you all know that? Or are some of you still at divide by 100, multiply by 10? Are you all happy with multiply by 0.1? Yeah, okay. Find 20%, 30%, 90%, 100%, 110%? Okay, that's an increase, yeah? If I want to increase by 10%, I actually need how much of it at the end? Well, if I wanted to increase the amount of money I have by 10%, as a percentage, what do I want to have at the end? 110%. How do I find 110%? Right, if I want to increase by 35%, how much do I want to have at the end? How do I find 135%? 1.35. Let's say, right, it's all about what do I want to end up with? That's the way we've got to think of percentages. What do I want to end up with? So if I want to decrease my debt by 10%, how much am I going to be left with? 90% of it, yeah? So what I want to do is find 90%. So the decrease, you have to do a little bit of mental arithmetic first. If I want to decrease something by 30%, how much of it do I need to have? 70. How do I find 70% of something? Multiply by 0.7. If I want to decrease by 25%, Izzy, how much do I want to end up with? How do I find 75% of something? Okay, so the thing you multiply by is what you want to end up with. Then you look at the result. Like what does that mean? So if I multiply something by 0.64, what percentage am I finding? 64%. So I have 64% of what I had before. So in terms of an increase or a decrease, if I only have 64%, has it gone up or down? It's gone down by 36%. So I have decreased by 36%. So here you go, look. An increase of 25% has actually decreased the other by 36.
Wow.
All right, slightly different to what you're expecting, yeah? So let's have a look. What happens if I increased my distance? You can work this one out. Same idea. What if I increase my distance by 30%? Go for it. Work it out. Increase distance. All right. So what happens to I if I increase D by 30%? All right. Hopefully what you did was, well, if D is multiplied by what? 1.3. Therefore, I is multiplied by 1 over 1.3 squared, which is the same thing as multiplying by 0.59. Okay, so how would I then? So I've got increased by 30%. So my answer should be I is decreased by, let's do 100 minus 59, which is 41%. So decreased by 41%. Okay, that makes sense? Yeah. Okay.
What did I do? What did I do?
Now that's like the typical question to do with inverse relationships where you increase by a percentage because it draws the quick incorrect answer. Yeah. Because people go, oh, if you increase by 20, then the other one must be decreased by 20 squared. Yeah, 400. So yeah, 20% for 400% decrease. It's just a quick reaction, yeah? But it's not quite the same, is it? Because when you increase by a percentage, you're not multiplying by 30 for 30%. You're multiplying by 1.3, which is something different. But if I said to you doubled, or if I said to you, or for instance, if I said to you D is trebled, what percentage increase would that be?
3 times 3.
But as a percentage. If I treble something, what percentage increase is it? Times 3. Multiplied by 3. If I treble something, go back up. This is an important one for you, with percentages in mind. If I treble something, so I've got 3 lots of it, all right, what percentage increase is that?
200 increase, which is 300.
Okay, is it 300% increase?
It's a 200%
If I say I want,
increase.
oh, okay, good, right, don't forget that. Because to do a 200% increase, what do you multiply by?
3.
3. A lot of people would do multiply by 2, wouldn't they? They go, I need, yeah, 200%. Treble something is actually a 200% increase, not a 300% increase. Because you already had 100%. So the increase is only the extra, isn't it? Okay? Something to look at there.